Friction.
There are many different types of forces that occur in nature, but perhaps none is more familiar to us than the force of friction. Friction is a resistive force that opposes the motion of an object. The sandpaper on this block resists movement across a piece of wood, therefore causing friction.
Friction is the reason objects stop rolling or sliding along a surface. It is the reason it is difficult to start pushing a heavy box along the floor. There are many different types of friction. Friction between solid objects and air is often called air resistance. Friction between a fluid and an object is called viscosity. There are two main categories of friction: kinetic friction and static friction. Kinetic friction is the resistive force between an object and the surface it slides on that opposes the motion of the object. Static friction is the resistive force between an object and the surface it sits on that prevents the motion of the object. Static friction keeps objects from moving when a force is first applied.
Where does this friction come from? On a microscopic scale, most surfaces are rough. Consider a blue box sliding on a red table with velocity v. When you look at the interface between the box and the table, it looks pretty smooth. But if you look through a microscope pointed at the interface, you would see a rough surface like this. The microscope image shows a rough surface between the box and the table. The rough surface slows down the box. The box surface bumps into the rough table surface and feels a force that makes it harder to push. Friction forces are very complicated, involving electromagnetic forces, mechanical forces, and thermal energy. Manufacturing companies spend hundreds of millions of dollars dealing with friction forces.
The friction force between two objects is proportional to a constant that is large for forces that have a great deal of friction. The constant depends on both object surfaces. The constant is high for wood on sandpaper, but is lower for wood on ice. Wood has less friction when it's moving on ice than it does when it's trying to scrape off rough wood with a piece of sandpaper. In general, any pairing with ice has a low constant, and most pairings with rubber tires is high. The friction force has both positive and negative impacts on motion. The disadvantages of the force are more apparent and include the heat produced by the friction force when metal parts in a machine move against each other, causing wear and tear on the parts and reducing their effectiveness and lifespan. Increasing the amount of energy to keep objects moving due to the friction force opposing motion, such as boats in the water, cars on the roads. Increased noise due to mechanical parts rubbing against each other. The advantages of the friction force are critical to the motion of people and of machines, but are normally not thought of. Without friction, people could not walk. When walking, a person's foot pushes down on the ground and a friction force pushes back up, like we showed in that example a few slides back. Without friction, think of being on ice. Walking is much more difficult. Car tires require friction, so when the tire rotates, it can move the car. Without friction, the tire would just spin and the car would not move. Again, picture a car on an icy road. It would not be possible to write with a pen or pencil, as they would just slide on the paper.